This is Rich, and today's going to be a tutorial continuing part 2 of my how to create an RTS game from start to finish in Cryengine 3 SDK. Been a lot of stuff I've been saying up on the CryDev site and also the YouTube site about switching engines, and some of you guys worried that I wasn't going to be continuing obviously my tutorials on the RTS. Just want to let you guys know that that's not true. Just to clear the record, I'm still working with Cryengine. I'm still doing everything I was doing with Cryengine. Nothing has changed. It's just that C++ is very hard for me to understand with Cryengine. And actually, hold on a second. Hold on. Alright, yeah, I'm back. Sorry for the noise out there. My fiance has some people over and they're being kind of noisy and playing music really loud. So just, ignore that. Yeah, so what's going on is C++ was hard for me with Cryengine. I am kind of familiar now with C++. I mean, I understand the basics now. I know how to create a function. I can create simple programs with C++, so that's not an issue. I do have a grasp of C++ from a lot of reading now. Still a lot to learn, but just looking at the Cryengine C++ and what they've done with it, it's just really, really, really confusing. I don't understand it. I'm not skilled enough to really make heads or tails of what's going on, and that's just very upsetting to me. So I looked over other engines for possibilities on being able to understand it and ease of use for an RTS type of game. And nothing really, at the end of the day, compared to Cryengine. I guess I have to sit with the fact that I'm just going to have to wait until documentation is released for Cryengine. So I'm back full-fledged with Cryengine, and that's going to be my choice. I'm going to be with Cryengine. So here's part 2 of that, how to create an RTS game in Cryengine. This is covering the diagonal movements with the mouse, and as well as the rotation using the arrow keys. That's what's going to be in this tutorial, like I said. But I also want to show you a little bit of an update on my RTS prototype on resource gathering. This guy actually will, if I right-click on this resource here that I've modeled and textured, and this is a custom entity that I scripted in Lua. There was no scripting. It doesn't do anything besides just the basic entity to get it recognized by Cryengine, and it has a specific class name. And this over here is a barrel modeled and textured by me. But you're going to think outside of the box here for a second. This is just a model representation of the of an actual main base. This would be considered like a main base in RTS game where you gather resources and drop them off at your main base. This is a main base. The scripting is a main base. It just has a barrel as a model, just for testing. So this is a resource entity, and this is a main base. Just use your imagination. So when I click on this resource here, he automatically searches the area and finds a main base to drop off the resources. And then he immediately scans for another resource place and then goes back. So he keeps going until you tell him to stop. If you stop midway, let's say you've collected 10 resources, max is 10, you collected 5, and you stop midway, you decide to bring your worker and move him someplace else, he still knows that he has 5 on him from last time. So if you right-click on your main base, he'll then go to the main base, drop off his 5 that he had, and then he'll immediately go back and find a resource place. That's how I've scripted him. He also not only finds the main base, but he also finds the closest main base. So if I had a main base here, and then I ended up building another main base right here. As he was already excavating, as soon as he's done, he's going to notice that there's a closer main base, so he'd actually go here instead. That's how I scripted that as well. And the scripting is actually through FlowGraph, all 100% through FlowGraph. The only thing it's not is these custom entities here. Again, these custom entities don't have any scripting on them. They're just the script to make them entities with a class-specific name. Both of these are scripted entities, and we're going to go over to create that in the third or fourth part of the tutorial on creating those custom entities along with the resource collection and drop-off excavation stuff through FlowGraph. But this is just the diagonal and rotation for camera movement. So let me just show you this little resource here. I'm going to go to Control-G to jump right in game. User control, this is behavior here. I'm going to left click on this guy and right click on the resource excavation. I'm going to move my mouse over here so you can see I'm not clicking on anything. And I'm just going to rotate so I can get a better view. My mouse is going to stay right here. I'm not going to click on anything. Look up at the top left hand corner of the screen. That's how much resources he currently has. When he reaches 10, because currently that's his max, it's not a limitation, that's what I put. I only want him to collect 10 at a time. As soon as he's done, he goes ahead and he finds a main base, which is obviously that barrel. He's heading over there. Right here is where the resources are stored after he drops it off in the main base. So you can see he has 10 now, and he's found another resource excavation, and he's going right back there immediately to continue. So basically this is a task that he's doing. He knows that he's collecting resources, so I don't have to click the resource, then the home base, then the resource, then the home base. He's on basically a task. He knows he has to resource collect, so he does it automatically. It's an auto feature, basically, that I scripted in through FlowGraph. So he has 10. He just maxed out with another 10 up there, and he's going to drop it off at the main base. And you're going to notice that the resource total is going to go up to 20. So let me stop him halfway. Let's just pick a number 7.2, or no, 7 something. We'll try to stop somewhere in the 7s, and remember that number. So what I'm going to do, I'm going to click in this empty space when it gets 7 point something. Let's see, 4, 5, 6, 7, 7.25. So now I've broken his chain to the home base. I've broken his chain to the home base. He's not going to go there anymore. He's going to do whatever I want him to do in case I don't want him to resource. I want him to go somewhere quickly before dropping it off. So he's now here. Let me just give him a couple commands. And move him over here, and then move him back over here. Okay, so remember he had 7.25. Let's go ahead and right click on this main base here, and you can see that his behavior is drop off resources. He's going to drop it off. If you look over here at the total amount, you're going to see 27.5. He had 20 and he had 7.5 on him. And then he immediately goes back and collects more resources. Let's just do this one more time. He's going to go up and then come back. Just so I want to show you that after stopping his behavior, then dropping it off to add it, he can go back again, collect his resources, and add to that 27.5. Just want to show it's a smooth workflow here, a smooth, addition going on. So he has the max out again at 10, and he's 27.5. So it's going to be 37.5 when he drops this off. There we go. He's at 37.5. I just wanted to show you that. I thought it was pretty cool. One more thing about that. Let's go ahead, take this main base, and let's duplicate it. Control-C to copy. I'm going to place it right here. Just like that. I'm going to go ahead and regenerate my AI. Just like that. And I'm going to go to Control-G to jump in game. Click on him. Click on the resource. Now watch what happens here. He's going to notice that there's a closer resource base than the original. He's collecting right now. He has 3, 4, 5 currently. And these values that he's currently collecting is actually being stored inside of a variable and being saved off. And he drops it off at that, giving us 10 total. Now he goes back. Now, the idea behind scripting my own custom entity, there's a couple of reasons why I did this. One, it's a way that I can specifically identify that this is a resource excavation, so that when it searches for a place to pick up resources, it knows what type of entity it's looking for. It's looking for a class name. And the class that this resource excavation belongs to is resource excavation. The second part is that I wanted to script it once. I wanted to script one entity for all resource collection, but have different models. So even though this resource excavation here looks like a cave with crystals on it that you can collect crystals from, it's one entity. So if I wanted to have 3 or 4 different, different types, different looking, resource excavation sites, what would end up happening is all I would do is I would just copy that, the main resource excavation entity, but then in its editor properties over here in the window, I just go ahead and change the model out. So same scripting, script once, but has different models. So basically, each group that you play as, depending on what clan you're going to be, you're using all the same entity, but you have different representations. So that's why I chose to use entity for these here. He's already up to 40 right now. But there you go. That's what I wanted to show you. So let's go back into FlowGraph and see if we can get this going here with the rotation and the diagonal movement. Since doing that tutorial, I have deleted that FlowGraph. Sorry about that. I'm not going to redo it. I'm just going to go over the new parts. I am going to just discuss from my already existing flow graphs what they do. It'll be the same as what I did in the last tutorial, except for I just won't be dragging and dropping the nodes in. They'll already be there, and I'll describe it. This is going to be, I'm going to try to be relatively quick with this, but very informative, because I want to cover a few things. Okay, so let's go down to, we've already done directional movement. Let's go to diagonal movement. So this here is a UI event, which is right-click, add node, UI, event, main RTS HUD, and you can see here. So this one here is bottom right diagonal move on rollover. That's in the bottom right direction. I want to move bottom right. And that's when it roll over. So when I roll over the button, it's going to move the bottom right. This is the exact same node, except for it stops the movement when I roll off of that button. So you have start and stop. Oh, excuse me. Oh, let's see what vector is being set. I'll say we have the entity's rotation. Okay, we're setting a vector, the entity's rotation, just like in our directional movement, left, right, up, and down. We have a set vector, and the vector we're setting is our rotation, our current entity or camera's rotation. This right here, we're also setting another vector, and this vector is controlling that it always goes down to the bottom right, no matter what way you're turning. If you're turned left, if you're turned right, up or down, doesn't matter. He's always going to move in the 45 degrees from where he is, bottom right. Okay, this is the direction, remember. We want to move in the 45 degrees direction from the entity. So if the entity is right here, we want to move in the 45 degrees, the bottom right direction from the entity, no matter what. Okay? Then we're going to add these two together. We're going to add the current rotation, the current rotation that the entity is facing, and then we're going to add 45 degrees to it right here, and this will give us the direction, right? We're going to add the current camera direction plus an extra 45 degrees to make sure we always move 45 degrees relative to the entity, and that's going to give us the total direction that we want to move into. And we're going to turn those angles into that direction, so we actually have an XYZ position, just like before, exactly the same. Then we're going to take the X and the Y position, because if we're going diagonal like this, you're going in the positive right direction and then in the negative Y direction, because when you're going diagonal. So you're going to go in the positive right and then the negative X, because you're going in diagonal. We're going to add that to a Z value like we saw before. It's exactly the same thing. We're just going with a Z value, just like before. After we do that, we're going to subtract the direction in B. Remember, direction in B, and then the current position. Remember the entity's position in A. So we're going to take the current entity's position minus the direction you want to move into, and that's going to be the destination. I don't need to go into too much explanation because it's exactly the same as the directional movement. The only difference is you're adding 45 degrees Z rotation. See, 45 degrees. In the other ones, you added 90 and 90 because 90 is a square, right? A right angle. 90 is a right angle. So if I'm facing forward, 90 degrees is left or right. Exactly. So since we're not going right or left or up or down and we're going diagonal, well, half of this 90 degrees that we added earlier is 45, which gives us a diagonal. So instead of, the only difference is between the directional movement and the diagonal movement is what you put in this Z value. So you could actually, quite honestly, copy your directional movement. Just copy any one, then paste it. And the only thing that you would have to do is, instead of just the X or the Y information, you're going to keep both. And then you're going to change the Z rotation. That's the only difference, the Z rotation, and you're keeping the X and Y value. That's it. It's the only difference. So I don't need to go over how to create the bottom right movement, the top right movement, the top left movement, because they're all the same. The only difference is the value in the Z. See, this one's negative 35. This one's negative 45. This one is positive 35. This one is 45. That's the only thing that needs to change, besides X and Y value. X and Y value. X and Y value. X and Y value. That's it. That's the only difference. Very, very simple. So change this Z value, okay? This Z value with here as well. All of them. Then just keep the X and the Y value. Obviously, you need these custom nodes here to start and stop. Now, previously, let's go to our directional movement. Actually, never mind. Yeah, they're exactly the same. Exactly. Once you've gotten that, you're going to jump right into game. And you're going to notice that if I go over diagonally at this diagonal, I go diagonal. Let's go diagonal the other way. Over this button, I'm going diagonal. Let's go over this button. Diagonal. Let's go over this button. Diagonal. See? Let's go ahead and rotate the camera a little bit. Let's go diagonal. Oh look, diagonal's diagonal, no matter which way you're facing. Let's face a little bit more. See? Just like that. Left is left, up is up, down is down, right is right. No matter which way you're facing. Just like that. That's your diagonal movement. Now we got to deal with rotation. Rotating left, right, up and down your angles so you can get right into the action, right up close and personal, and be able to rotate to see what's going down. Again, cameras, unit selection, unit movement. These are in resource gathering. These are very important specifically to an RTS. That's why we're going over this. This is the RTS, how to make, and we need to know these things. So let's go down to the camera rotation. Okay? Camera rotation. I have 4 nodes. These are input key nodes. We're going to right click, add node, input, key. For key, obviously, key, this is what key you press. When is this press going to output? When is this release going to output? Well, of course, when we press the down key, the down arrow key, spelled just like that. That's what it's going to output this or output this based on if you're pressing or releasing the down key. You want to make sure that non-dev mode equals 1. You want to make sure that's fine. It does not need a choose entity. It only needs this for multiplayer. And in that case, you assigned you, the local person, to this right here. Enabled, it's enabled by default, so you don't need anything going into enabled. You don't need anything going to disabled. Key down. 4 of those keys. There's 4 arrow keys. We need 4 nodes. Up, U, P. Right, R-I-G-H-T. Left. Need to be spelled exactly like these. These are predefined names that are recognized by Cryengine, mapped to the keyboard buttons. Let me just reflect on how I did this so that I can teach you. Okay, what's going into that? Let's see. What is going into that? On released. No, that can't be going into on released. Yeah, it's not going on released. It's just going right through the node. Rotation. So we're going to be dealing with the entity's rotation. Okay? The entity's rotation, because we're going to be turning, which is rotating. So entity's rotation. Entity's rotation. We're adding a vector to -1. I see what this is. This right here is calculating my detection if it's past 90 degrees or not. And if it is 90 degrees, go ahead and stop rotating the camera. Actually, oh man, that was funny. I should have done this. Actually, no, I shouldn't have done that. So 90 degrees is going to stop. Yeah, that's what Let me just test this out because this would be a lot easier. Sometimes, you know, when you do something and then you get really involved in trying to figure it out, and then like, you know, you learn some things, and it's like you look back at your old stuff, you're like, wow, why did I do that? There's so much easier way to do that. Well, I think I just had one of those moments. Down. Let me go ahead. I'll save it, I'm confident. If not, I'll just redo it. Let's rotate down. It does stop, but not completely. Yeah. It starts to stop, go, stop, go, stop, go, stop, stop, go. Alright. So there was a perfectly good reason why I did that. Do 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 do. Do 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 do. Let me try do this here real quick, and I'll describe what I am doing. Oh, I'm good. I'm holding down and it's not moving anymore because I hit that 90 degrees. Damn, I'm freaking good. Alright. Yeah, I can fix that issue right there. Yeah. Like I said, looking back at my stuff, it's like, okay, I should have done that differently. Let's try the up and down, because that's what I modified. I'm going to save it, because I know that process works. And I'm going to explain it. I'll explain it pretty well, guys. Don't worry. Let's try the up. Stops. I'm holding up. Let's go down. Stops. Perfect, perfect, perfect. Just rotate. And then go up. Just debug. And it stops. I'm happy, happy, happy. Alright, let's go over how to create the rotation. Okay? Alright, so what's going to happen now is this. We already described that we're going to need these key input nodes to detect our key input. Okay? And we got the entities rotation, which is our camera's rotation, and the add vector. And why do I have -1? Why the hell is there a... Oh! Man, I'm... Oh, excuse me, guys. That's gross. Okay, so the stop number, we're going to add a vector. Okay, add vector node, which is right-click, add node, vector 3, add vector. The reason why we're doing this is because this top one obviously saves our current rotation, and we're rotated. Our camera's facing the terrain at a 45-degree angle, if you saw, and that's on the x-axis. See, x, y, z. Our camera is facing downwards in a 45-degree angle, which is rotation of 45 degrees on the x-axis. So every time we hold down, every time this node updates, we want to move 1 unit even more down on the x. So every time we hold the down button, we want to take away one degree of rotation. That way, every time it updates, you'll see the camera going down and down and get down and down and down and down. It's because we have the current rotation, and we're minusing 1 from it. Every time
a vast virus database has been updated.
Every time this node is output. See? So we have the current, we're adding the current rotation, which is in the downward facing the terrain 45-degree angles, and when we press our down key, we want to go down 1 unit. And then if you hold it down, we want to go another 1 down. So in effect, it's just scrolling down slowly. If you want a really, really fast movement, if you want to hold down and you want it to move really fast down instead of slow like I have it, you just increase this to like a -2 or a -3. That's just how you increase the speed. The more you take away, the faster it's going to move. And we're sending this direct input here. We're sending the new rotation to the rotate entity 2. Remember before it was move entity 2. But we're now rotating entity 2. Very, very simple. We're taking the current camera rotation, which is 45 degrees facing down on the x-axis, and we're minusing 1 on the x-axis, making it a 44 rotation, 43 rotation, 42 rotation every time we hold down key. So that moves the camera looking downwards more and more and more. And that's being output directly to the destination. But then we want to find if we're, already at -90. That's how I program. I don't want to rotate full, somersault, over and over and over. So I want to say, okay, when we reached 90 degrees, if we're facing directly down, 90 degrees, remember, left, right, up, down. 90 degrees is facing directly down or directly up, depending. -90 could be up, +90 could be down. Or positive 90 could be up, negative 90 could be down. So we're dealing with 90s. We want to detect if it's 90 degrees. If it is, obviously stop moving no matter what. Don't move. So we send this up to, see, we already told it to move, but we're also going to send this rotation up to the from vector. And because we're dealing with just the x-axis, x rotations, we only want the x information. Then we add a math less, because they don't have a math more. It's ridiculous. You have a math less, but you don't have a math more. Less than, more than. They only have a math less, which is stupid in my opinion. Math less can also be used as a math more than as well. It just depends on what you input, A or B. To detect if something's less, you put A is A less than B. But if you want to detect if A is more than B, you put the what would be in the A into the B and what would be into the B to the A. You just reverse these. So I put the X rotation into A, and then the B rotation negative 89, because what this is asking, because this is a math less node, I want to detect if it's more than 90. So what I'm going to do is the X rotation, okay, is it less than negative 89? That's what I'm saying. Is the X rotation less than 89? This is how I'm detecting if X is more than 89, because I put it on the A slot and not the B slot. You just reversed. If you want to find out less, and you would put it A to B, a value into A, value into B. But if you want to find out what's more, you would put that value into B and the other value into A. You just reverse these nodes. So I'm checking: is our current X rotation, is it more than 90 degrees or 89 degrees? And if it is, right, if it is, go ahead, feed it into the any node. This any node is connected to the logic gate. I'll describe this in a second. Okay, this is output to the close. If it is true, if it is more than 90, go ahead and close this gate. We don't want to send any more information out of the output. Stop sending information out of this output. Okay, so when it is 90, if it's more than 90 degrees, go ahead and close this gate, which in turns, logic gate, which in turns stops outputting out of this. But what is it outputting to? Let's see. Start. See, it's outputting to the start. So look at it this way. First we output. We move the camera first. That's the default action. The default is to move, then check. Move, then check if it's 90. So what we're doing is we have the current rotation, negative 45 facing down. We want a -1 every time. -1 from the x-axis. Oh, we're adding. See, we're adding a negative number. It's weird. But we want to add the current rotation to a -1 in the x every time we push down. So it's going to take 1 away from the rotation every time, in turn making it face down and down and down and down and down. See, we're outputting it. And then we're also, at the exact same time, checking if the x value is more than 90. And if it's true, if it is more than 90, go ahead and close this node, which in turns stops starting it. Sounds weird, but it does. It means it's not going to start it at all, because this start input is not going to receive any notifications to start. Why? Because this gate is now closed. Nothing is outputting. So this will never be activated. So when it's true, when it's more than 90, put logic any, which basically outputs here whenever something on this side is received. In this case, true would output, making this receive an input, making this output to close it. Now, this won't know that it has to start, and in fact, it will stop it because it's not starting anything. It knows don't start it. So there we go. That's how we control if it's 90 degrees or not. But what goes into the in value? Maybe I should first describe what a gate is. A gate is a logical expression, as you can see, logic gate, add node, logic, gate. And what it does is, you have an in value, which is like, let's say I put in 10. I put 10 into this slot, so it has 10 of a value. And then 10 outputs, see? In goes 10, whoops. In goes 10, out goes 10. But under what conditions does it output? 10 could go in here all day long, but it's only going to output 10 when the time is right. And that's what these open and close is. So whenever the gate is open, it goes, okay, let's send it out, let's send it out, let's send it out. When the gate is closed, it says, don't send it out, don't send it out, don't send it out. Well, what is this going to? This is going to the start. So what opens? What tells it to start? If you look, see open. Let's follow this up here, follow this up. When we press it. So when we press down key, so when we press the down key, it's going to open the gate. What happens when you open the gate? Obviously, it's going to output and start the update. So when you're pressing down, it opens the gate to start the movement. When it receives, when it knows that it's more than 90 degrees in the down direction, it says, close that gate, stop moving. And what closes it? Well, we have this logic any. There's two things that close it. One, which is if it's more than 90, see, logic any goes into the input 2. That will close it. What else will close it? Because there is one right here. Releasing. So when we're holding down, we open the gate and start the movement. When we release down, we close the gate, stop the movement. And we also close the gate, stop the movement when it's more than 90. That is how you move down. Very simple, huh? Very, very simple. Now, how do you do moving up? Same exact thing. You can literally copy everything here on this down movement, rotation, and copy it one for one. There's no difference except for this is key up when we press the up key. And instead of -1, we're adding a +1. See? Up here is -1 to go down because we're taking away, which is going down, -1. And then we want to go up, so we add 1 to the rotation. Get it? Very, very, very simple. Everything else is exactly the same, copy and pasted. Just change the -1 to a +1 here. Okay? And change this to up. Exactly the same. The reason why you do this, because we want to go up. We want to add. We want to go up on the x-axis, not down. See, when we take away, we go down. We get less and less and less. That's why we go down. But when we add a +1, we go up, 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 because we're adding. So, moving up with the +1, moving down with the -1. Now we got to go left and right. Very, 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 very simple. This is even more simple than the up and down, because when we're doing left and right, we're not calculating if it's more than 90 degrees, because left and right, we want to go around in a carousel, a round and round and round. We don't care how many times we go around, left and right, no problem. So what we do here is we take the current entity's rotation, right? Their current rotation, which in this case, it's -45 on the x, because we're already facing down. It has a 0 y and a 0 z. Well, if you're going left and right, you're actually rotating on the z axis, x, y, z. We're rotating on the z axis. So if we want to go, ready? Right. If we want to go right, okay, which is positive x. Remember, right is positive x on the coordinate system. So we want to go +1. We want to subtract. Again, this is a, kind of like an oxymoron. You're subtracting a positive, positive, stuff like that. But what you do is subtract node. Vector subtract. So you want to take the current entity's rotation. In this case, we're talking about the z value, because it's left and right, which is rotating on the z value, left and right. And we want to add 1 to the z value, because we want to move right. See, it's a positive number here, because right on the coordinate system is positive, left on the coordinate system is negative. So we want to subtract a positive number, not a negative. And that goes right into destination. Current entity rotation, subtract 1 from the z rotation to give it a new rotation of right. 1 little meter right to where it currently rotated, to get a nice smooth right movement when you press down on the right key. We want to rotate right when we press the right. Just like that. Very, very simple. Right into destination. Oh, and these rotate entity 2 have the game camera, which I changed this since. This would be your camera entity that you dragged into the beginning. The same camera entity. Now we're going to want to know when we stop and when we start. When do we start and when do we stop? When do we do that? Well, remember logic gates. A gate takes an input, let's say it gets 10 on the input, and it outputs 10, but based on certain conditions. The conditions are whether it's open or whether it's closed. If it's open, it goes ahead and it outputs 10, 10, 10 all day long. If it's closed, it stops outputting. And this is connected to the start, so it's going to start rotating the entity when the condition, this gate here, is right. What value is going in? Well, this logic any node right here. When we press it, so when we press the right key, press the right key, we want to open the gate. Press the right key, we want to take that value into in and then pass it out to start. So basically, what's happening is when we press the right key, we're starting the movement. But what conditions have to be right? Have to be met? Hold on, this seems like a... What conditions have to be right? I don't need that. And I don't need that. Well, we have to be pressing the key. That's all. Pressing the key. So when we're pressing down on the right key, we're pressing the right key. We're going to open the gate, therefore sending our pressed signal to start. So all this does is when we press the right key, we're going to open the gate, right here, open the gate, and we're going to start the movement. So very simple. We tell it the new position, and then we start it by pressing right. But when we release, when we let go of the right key, we're going to close this gate, therefore not sending any start signals. It's not going to move when we let go. Same exact thing to the left, moving left. You can literally, again, copy the moving right flow node set, copy, paste, so that you can make another left flow node set, except for the difference is this is key left, L-E-F-T. And for the add vector, because before we subtracted a vector just like that, we're going to add a vector. Actually, that was my bad. My bad. Add node, vector 3, add. They're all adds. They're all adds. All add vectors. None of these should be subtract vectors. They're all add vectors. Add vectors on the up and down, and add vectors on the left and right. None of them should be subtract vectors. Let's get rid of this. Boom. Destination. Remember, we want the entity's current rotation. Let's go down to that entity position. We want the rotation. Let's drag that up, 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 up. Into the A slot. Only thing is because we're using add for this moving right, we're going to add a -1. A -1 in the Z to move right. We're adding a negative number. Here we want to move left, so you make a +1. We're adding 1. Very, very, very simple. So to move left, we're going to add 1 in the Z direct rotation, and then when we move right, we're going to subtract or add a negative number here. That's it. You've got your diagonal movement and your left, right, up, and down rotation. So let's go ahead and file, save, press OK. Let's jump right into the game, and here to here. Jeffrey's is our son's friend. Okay, seems like he's crying. Hold on, guys.
You know that little black one? He's asked you where it came from. You're like, I don't know.
I think it's on the coffee table. So let's move left, right, see like that, and let's move right, just like that. Let's move up, and let's see if the 90 degrees is still in effect, and yep. Let's move down. Just like that. Perfect. So we've now gone over part 2 of creating an RTS game in Cryengine 3 SDK. Thank you very much. Please comment and let me know how I did, like always. Thank you very much, and I appreciate it. All right. Bye.